start recording this training so that in case we have any interruptions, we have somewhere to go back to. So allow me to present again. Okay. So this is what we are covering on mobile products promotion. We're just going to look at the different parts. So first, we're going to analyze the system itself. Then we compare the solutions and some cases before I switch to another presentation which shows the different parts. So start, we have this overview here, and this overview focuses on the wide range of mobile products provided by us. So starting from the platform itself. So this is the management software. We usually station it somewhere where anyone else is going to access the different vehicles. And then in the event there is an incident, this way it's reported. In the event there is an alarm, this way it's reported. And it also does the management and emergency information release and such things. Then in the same category, we have the recorders, where we have the MXVR and MNVR. MXVR is the typical DVR or analog recorder. So it means that the analog system, we have the 1004, 4104, 8212, 9124. So just generally based on how it is named, 4 is for 4 channels, 12 channels, 24 channels. Then we have the MNVR, which means that it works with the IP cameras. So we have the 4104, 4 channels, 4208, 8 channels, 8104, 4 channel, and 8108. And one thing you'll notice, all of them have a dash I at the end, which symbolizes that they are all AI recorders. Then we have active safety, starting with the driver status monitoring camera or DSM. Then we have ADAS, which is the advanced driver assistant camera. Then we have the BSD camera, which is the blind spot detection camera. Then we have this all-in-one, and I'll explain what all-in-one will do. But before I touch, actually, let me just touch. We have the dash camera. This is installed on the dashboard facing the road. Then the DSM camera is another all-in-one, but it's installed facing the driver or the yes, the driver and his co-driver. So the logic is, because it's called an all-in-one, we would have a SIM card can be installed inside. We have an SD card also installed inside in both of these recorders. They both support Wi-Fi. They have GPS built in. And pay keen attention on this dash camera because it's one of the products that are involved. Then after reviewing this, I'm not mute unless you can't hear me. Just check. Harrison, unaweza nisikia? Okay, so I can be heard clearly. So just check your audio settings and join with audio kindly. All right, then we have the DSM camera, so I've been talking about. So these two cameras are actually doing some typical opposite. So about the dash camera is it requires a DSM camera that connects to it to face the driver, and it can take two more HDCVI cameras. Then the DSM camera I would require maybe a camera facing the road and two more. So all of them are still 4 channel as much as they are all in one. Then we have the HDCVI cameras. So we have these models and designs based on installation. Then we have the IPC. These are IP cameras. We have these designs. Okay, so we have like this dome, the rugged design, the driver status monitoring camera. We have this fisheye camera. Then we have the people counting camera. You understand that IP cameras are usually can work standalone, and in this case, they will work with this MNVR. The HDCVI camera will work with the MXVR. Then we have these accessories like a screen, 7-inch screen. We have intercom. We have the alarm button. In case of emergency, we have the keyboard, the backup box. Okay, the accessories. So that's what I'm talking about in this case. So we've looked at the different accessories we have. Then you are going to forgive us for we're having a lot of connectivity interruptions, so bear with that. I'll try to record this all and then combine and share the video at the end of the training, but try as much as possible to follow. Then let's now analyze the different MXVR and MNVR. So MXVR 104, so you just look at the different models. So look at this, video input is 4 plus 1, so that's like 5 channel. 4104 is 4 plus 4. Then 812-I is 8 plus 4, that is 12. 4104, 4 channel, 8 channel, 6 channel, 8 channel. Then we have supporting storage of SSD, HDD or SSD, and SD. So these are memory card. So each, apart from MXVR 1004, support at least HDD and SSD. They also support SD card. Then we have AI that they support. So we have DSM, driver status monitoring, DAS, advanced driver assistant, BSD is the blind spot detector, and then face recognition. Then the other bit, these two support the same functionality, but the 12th channel supports an extra functionality of HOD, ANPR, and face recognition. Then, in addition to MNVR, it's DSM by IP. So it means that the camera will do the work of driver status monitoring. Then we have an extra functionality of face recognition. And ANPR, we also have advanced driver assistant. So based on the functionality you want to achieve, it will guide you to choose the correct recorder, in that case for the vehicle. But in the mobile world, HDCVI is more popular than IP. Then we're just trying to do some comparisons on the same MXVR and MNVR. So all of them support GSM. Advanced Driver Assistant MNVR 4104-I and 4208 does not support. BSD, blind spot detection, I can see it's supported only by MXVRs. Then we have HOD, which is only supported by MXVR, 12 channel, and that's it. Then ANPR is supported by all apart from MXVR 1004 and 4104. Then all of them support face recognition. Then we compare their algorithmic capability set. We have 1 channel driver status monitoring, 1 channel advanced assistant, or 1 channel face recognition. So it means you can't have both. You can just have either one or two. The same case for this 812. So I'll be able to share this material so that you can compare and get whichever the function you need. Then we have HDCVI cameras. So these are different cameras. And if you look at the connector, it is a 4-pin aviation connector. So we have some samples in here, and this is how the 4-pin would look like. It also has this curve here, and the objective is so that there is no mismatch when plugging in, so that you don't plug in maybe the ground into the video and such things. Then we have this model HMW 3200, which is 2.8 millimeters, which means the angle is wide. We have this 3200, 2.1 millimeters. Then we have this with two lenses, 2.1 millimeter facing the rear and 2.8 millimeters facing the front. It's a face recognition bus camera. Then we have this 2.8 and 3.6 millimeter lens variation. Then we have this model 2.8, this model 0.1. We have this 2.1 and 2.8 millimeter variation. Then we have this model 2241F-M-A, which supports WDR and is 2.8 and 3.6 millimeters. Then we have this DSM camera, which is 4 millimeters. ADAS, Advanced Driver Assistant Camera, which is 6 millimeter. Then we have the BSD camera, which is 2 millimeters. And maybe someone would ask why the millimeters are varying and all that. So I'll just confirm to you that we have, let's say, 2 millimeter and 4 millimeter. 2 millimeter will give us a very wide angle of view, but the view distance will be short. The 6 millimeter will give us a narrow angle of view, but the distance coverage will be relatively longer. So that is the variation. So the lower the lens, the higher the angle of view, and vice versa. Then for IP cameras, we have the MW23230D-H/V, variations 2.8, 3.6. And if you look at the connector by default, it will come with an RJ45 that is PoE powered for some models. Then there is also an extra 12V external power for models that don't support PoE power. Then we have 4-pin aviation. So we can also find an IP camera with 4-pin aviation and 6-pin aviation connector. So these are variation that we would get for IP cameras. And remember, for HDCVI camera, it's only one variation of 4-pin aviation connector. Then we have this CPC524. This is another type, also coming in different variations. It's a new model. I'm thinking it will even phase out these two models. Then we have the 5441F-E2, which is 2.8 and 3.6 millimeters. Then we have the fisheye series for the same. Then we have this HMW 3230, which is 2.8 and 6 millimeters. Then we have the people counting dual lens camera, which is 2 millimeters. So a very wide angle of view. Then now let's compare all in one in the mobile world. We have this CDMS 8113-GFW. We compare, it has a 720 pixel camera embedded. It has DSM built in to monitor the driver status. You can install a memory card of maximum 256 GB. It supports GPS, 4G, and Wi-Fi. So for connectivity, one, we have GPS, which uses the microwave signal connecting to the satellite and can give us the location of the vehicle at any given point in time. Then we have 4G for video transmission and Wi-Fi also for video transmission. It supports 3 external analog cameras input. Of these 3 external analog cameras input, we have the advanced driver assistant camera, which requires an external camera. So this advanced driver assistant is one, then we can add 2 more analog cameras. Look at functionalities this all-in-one camera can give. We have fatigue, so it will tell us when the driver is fatigue driving. Driver is making phone calls while driving. The driver is smoking while driving. When the driver leaves the vehicle, it will tell us. When the driver is distracted, there's distracted driving, then it will tell. It will also do face comparison to make sure that it is the actual driver of this truck that is doing the driving. So these are a typical setup we will get for a truck with 4 cameras. So this is typical on long distance vehicle. So we can put 4 cameras in that setup. This is the simplest kit you'll ever have for Dahua mobile products. Then we have this, another all-in-one. This one, the camera itself is slightly bigger because it focuses on capturing what is on the road. It requires it it has a built-in advanced driver assistant camera. It has the same support for memory card up to 256 GB to 2 slots. So it can take maximum of 512, but broken down with 2 SD cards. Then it supports two-way audio, so you can also talk remotely to the driver. Again, 3 external analog cameras input. And this of these three, one is the DSM, the driver status monitoring camera. So this the first combination, then we have the second combination, which now does the opposite of the first one. But it also supports GPS, so we can always know the location. We have 4G and Wi-Fi. Then we have these other features it will give you: forward collision warning, lane departure warning, and then when vehicles are getting too close, it also gives us the warning that there is a vehicle approaching you closely from behind. So take caution. Then so some of those functions, these are typical DSM camera monitoring. So remember, DSM is covered here. This one requires an external DSM, and this is what you get when the driver is yawning, when the driver is closing eyes, when the driver is smoking, when the driver is distracted, maybe making stories while driving, when driver is making phone call, if the driver is wearing IR blocking sunglasses. So you need to note this for that case. And for the normal MXVR and MNVR, we will get this kind of DSM cameras to supplement it. Then we have advanced driver assistant. Advanced driver assistant camera, this is the typical you will get. Warning for forward collision, lane departure warnings. So if this driver is just trying to change the lanes or legally trying to change the lanes, such things. Then rear headway monitoring, or if someone is driving too close to your vehicle and such things. Then we have the blind spot detector camera. This blind spot detector, the objective is mainly for big vehicles, buses, trucks. We install it on the side. Then it can tell us if there's an object approaching, maybe to prevent the driver from turning too fast or hitting objects. So it can detect human, cyclists, motorcyclists, and then other vehicles. Then we have the passenger counting camera, which is able to monitor the number of people entering and exiting a bus. It's equipped with a learning algorithm that can track count people in an area, the accuracy of 98%. Then it can work with MNVR and Mobile Center. Mobile Center is the platform which I'll also show you. Through site distribution and GPS tracking, the system supports to output detailed reports, the number of people getting on and off at each station, helping the bus companies to optimize scheduling, and also accountability. Also, I'm thinking is also it's a key thing, because we want to know how many people boarded, how many exited at what stops and such things. Then we have the dual lens and single lens. So the choice of the camera is based on the actual site or scene requirement. Then we have the 360 degrees surround view camera. This is coming. And the objective is, it gives the driver this kind of view. It tells you this is your vehicle, but on the left, there is this, on the right, there is this. So it supports to draw detection area divided on 3 levels of alarms. So we can check the color of the detection box uh, and get warnings in the event there is imminent danger or threats towards the vehicle. Then we also have this coming soon. Also, it's another blind spot solution. So we'll have this indicator in and out of the vehicle. Inside the vehicle, we get the warning and such. So we are looking at 95% accuracy and already certified by these different bodies. The objective is uh, actually, before I proceed, I just want to highlight this camera is 9 to 36 volts, but all the mobile products I've highlighted usually work between 6 to 36 volts, which gives their performance optimized because in a vehicle the voltage fluctuation is usually very high, but we can use this to to stabilize and sort out. Then we have this other item coming soon, which is the CBS 8210, a smart IP camera with built-in top and rear view lenses for detecting pedestrians and cyclists. So that kind of warning we install here, an alarm indicator to give warning. At the same time, inside the vehicle, we install the inside alarm indicator so that we warn the driver of impending danger and such things. So our application case for these vehicles, we have for logistics, we have taxi, we have the bus solution, patrol car solution, and school bus solution. And the objective is to give a safety, compliance, and efficiency kind of solution. Then for bus, we have this level of product design. So we have a rear view camera, which is installed at the back of the bus, passenger monitoring camera, and dual lens. Then we have the screen, 7-inch screen at the front. We have the panic button. In the event of emergencies, you can press and the monitoring center is where then we have the intercom to communicate. You can connect it for the vehicle public address and also to talk with the center. Then we have passenger counting with the dual lens or single lens AI camera. We have the blind spot detector camera, advanced driver assistant camera, the driver status monitoring camera. All this connecting to a mobile NVR or mobile XVR. Then through GPS and 4G, we can link with the center. We use mobile center platform connected to EVS storage. And then we use this client PC to monitor what is going on and all that. Then for logistics, we're looking at these options. There is a door contact or door sensor uh, to monitor. Then we have blind spot detector to check different approaching objects. Then we have inside the cabin, we have the driver status monitoring camera and advanced driver assistant camera. In the luggage area, we have the inside camera to monitor the luggage. And as we speak right now, we can even provision some solution to detect the loading capacity, loading rate of this luggage area. So if it's 50%, the camera detects and relays the same information. Then this is relayed through 4G, and we can get the driver status, the vehicle status, and the cargo status on the same platform. Then we have this topology for a police car. We'll have the ANPR camera here fixed. ANPR is automatic number plate recognition. We have the mobile PTZ also at the top so that the police can change the position, zoom in and out of different items and all that. Then we have the keyboard to control this PTZ. We have the touch screen for police to perform face search, number plate search and such things. Then we have the panic button in the event of incidents and all that. Then it also supports intercom connected to an MNVR8-I. Then we get GPS signal and 4G from this car. So if I have 50 vehicles, I'll get 50 signals on the same platform. And this platform even supports a map that you can pinpoint. Then we have the school bus solution. This school bus solution, we are looking at the front camera. We have the siren, we have the motion sensor, we have the cabin or inside the bus cameras. We have the LED indicator, we have the driver camera, the MNVR, we have temperature and humidity sensor. All these still integrated in the same recorder. We have the motion sensor also at the back. Then the check button. We also have extra functions. So we get CCTV for the school bus. We get face recognition attendance for the school bus. We get student check system. That is the panic. Then we have the temperature and humidity monitor. Then stop arm capture. So this kind of setup, we get it still in the same setup. And the objective is to make sure the school bus is as efficient as possible. Even with integration, as a parent, you would know, for instance, if the student comes into the bus, they do a face recognition attendance check, you get an SMS notification. So this can be supported to do integration with the SMS system. Then we have for the taxi. For the taxi, we look at this perspective. We have the cabin camera. We have the dashboard camera facing the front area. We have the rear cabin camera. Then we also have the driver status monitoring camera. So 4 cameras in one solution. So that kind of setup. Then some case, we have the Argentina bus project. In this case, we have the bus industry, 12,000 MXVR. So that's like 12,000 buses with 4 cameras. So that is 48,000 HDCVI cameras. This is a big project managed. Then we have the Turkey bus project. And with this, we have 7,500 MNVRs and 30,000 IP cameras. So that's a typical, so you can see the installations within the bus. Then we have the Mexico police car project. Just look at the installations on the vehicles. I'm sure the language barrier might prove a challenge, but the camera can be viewed and such things. So that's the objective. So if you look at the vehicle, it has a camera. Inside the vehicle, you have a camera. So that's typical setup we have. So multiple vehicles have a PTZ camera, we have camera inside and all that. Then we have the UAE school bus project. So in this school bus project, we're looking at 3,000 MNVRs, that's 3,000 vehicles and 21,000 IP cameras. So that marks the end of the camera introduction. Now I'll proceed and share the platform. We call it mobile center. So this is the management system, and I'm just going to use the version 2.21 of the same platform, but you'll understand that the objective is to understand that we have two levels on the vehicle itself and also at the center. So we use this mobile center and look at the features it has. First, database management and the NPR database management. We have site and line management, local play. Then we look at the topology. We look at the main functions, the highlights, then that covers it. So new features in 2.21 is first database, NPR database, local play, site and line. So for face recognition and the NPR, there is licenses that you have to apply in the same case. Then we have, so you can look, we can create a face database, add the number of people, and then we can choose to arm. Then you select which vehicles you want to send this specific database, then you distribute, and then that's it. So once you add someone is on the face blacklist alarm, it triggers an alarm, and then you get the notification on mobile center the moment this person is detected. For instance, in a police car, for face and vehicle blacklist would be necessary. Then we have NPR database management, the same logic. We create a database, we arm to the specific vehicles. So if this vehicle has been sighted in location X, then we can arm all the vehicles within that same locality, and then we get the notice in the event we have incidents. And you can look at the quantity of NPR database is unlimited. One single database supports 1,000 license plates. So if you have more than 1,000, you create multiple database of different plates. Also, we have the NPR blacklist alarm. So if a specific vehicle is noticed, then we trigger a notification to the center. Then we have site and line management. So we have adding a site name by coordinates, then the radius, so that if the vehicle goes outside this specific site, it triggers an alarm. Then, so this is the typical site and line. So you can add these coordinates. If you leave point 1, you have to go to point 2, point 3, like that, up to point 6. So if a vehicle maybe leaves point 1 and goes direct point 4, it triggers an alarm which will help in management. So such things. Then we have local play. So you can play the video, download the video and use it. This is directly from the device. Then the topology. So it will support the main VR, MX VR, and all-in-one camera. And the objective is we get video monitoring, we get vehicle management, we get danger driving behavior. We can also use it to do investigation and vehicle record statistics. This can be applied for coaches, bus, school bus, truck, taxi, and police vehicles. Then the topology, this is the typical topology you will get from mobile center. So we have the MNVR with all these cameras, which already we have reviewed, connecting to a 3G or 4G network. Actually, there's research for 5G network. Then using the GPS, we send the satellite signal, and on the map, we can even pinpoint the trajectory and current location of vehicle. Then we also get the videos and events recorded and stored. We have the M70 to display the live view on a video. Then we have some of the main functions you will get. So we have license activation. Oh, I'll leave the license activation because it's a typical case. Once you get the license, we can help with this. Then we have manage your devices locally and remotely. Then visualize the progress of the upgrade, if the upgrade is complete and such things. Then we have easy to deploy the system, as it's easy to do batch device configuration. So from the same platform, you can do device configuration, encode the parameters, change any settings on the MNVR in such things. So it doesn't mean that you are restricted to only when you're installing. You're also allowed to do this even after. Then we have other configurations like the interval to upload GPS data. It could be after a specific distance is covered, or time. Then you can also enable location analysis. Then we have active safety management, things like monitoring the driver, driving drowsy, smoking. So you get all these alarms as they pop up, and then you can use this to enforce action and all that. Then we have advanced driver assistance. Advanced driver assistant, we have forward collision warning and lane departure warning kind of alarms. So if you make such kinds, if you get such kinds of the alarms, the driver will be notified. At the same time, it is synchronized to the same management center. Then we'll get the list of these alarms, which we can choose to mark and complete. We'll also get the alarm analysis in this case, in this design. So how many alarms, which ones. So we'll even categorize, and you can use this for business analysis and to improve the nature of business. Then you have the operation panel, and the objective is to give us things like how many vehicles are online rate, what causes them to be offline and such things. Then we have uh, these functions in the monitoring center. So we'll do real-time previews on of videos, alarms, and also on a map. We can do the e-fence so that with standardized driving behavior, you can't cross specific areas and all this. Then we can use this to do investigation, playback and tracking of vehicles. Then we can use statistics for alarms and GPS. So in the live view, this is what you'll get. Inside the vehicle, the camera's monitoring. Uh, there is a map giving us the typical location and path of the vehicles. Then we have the map plus video, so we can also combine the two. Then we have live view. So this is the typical live view. Even you get the live alarms and all this. So like in this bus, if it's overloaded, you get the alarm that there is overloading inside the vehicle and all. Then we have audio talk, so that you can do two-way talk to the driver and tell them to avoid maybe committing that offense or making that mistake while driving. Then we have key monitoring points. So when you say key monitoring, it means that we are going to filter. If I have 40 vehicles, only the key vehicles will show up when I click switch to key monitoring. Then I can just monitor those specific vehicles. Then we have e-fence. E-fence, you can draw like that specific zone. Within this zone is where the vehicle is crossing. If it gets out of the zone, we get the notification and we can do enforcement. Then we can use this during investigation to track the path and trajectory, do playback, and see all the alarms at the same time. Then we can get also vehicle statistics, and the objective is all these statistics can help to improve things like mobile alarms, e-fence alarms, active safety alarms, GPS mileage, abnormal GPS, and more details on GPS. Then this supports also a DAE VMS mobile app, and the objective is you scan, you download the app, and then you're able to follow this. So you're not just limited to one location, or maybe to the monitoring center. Then some extra features we get on this. It is a distributed system. So the main server, and we can support sub-servers, and it can take up to 10,000 channels of IP cameras. We have the MPT, which is the body camera, so we can supplement that, and some MNVRs. So up to 5 sub-servers, 12,000 devices, 10,000 channels. So we can weigh based on this. Then we have the hot standby functionality. Hot standby means that the main server is running and the hot standby server is running. If the main server failed, then the hot standby server will peak and the operation will run as if nothing has happened. And how this achieve this, there is a keep alive database sync that's always happening. So when the main server fails, it automatically switches to the hot standby server. And when we restore the main server, it synchronizes. Then the system supports backup and restore. So I can save all my configuration so that if it ever failed, I can just install the software again, then restore from my files. Then I can schedule records based on time, and also maybe connect proximity to Wi-Fi to save on the cost. So that covers the introduction we have about Dahua mobile products. And at this point, I would like to mark the end of this presentation and welcome any questions that you may have based on what I've shared. Also, so any questions, kindly just unmute your mic and talk so that we're able to discuss.
The name is Mwando, right?
Yes, yes.
Okay, thank you so much for the presentation. I have a few questions here. Can I just ask them once, then you answer them once?
Okay, it's fine.
Okay, you've talked about the advanced driver support system and the DSM. I would like to shed more light on the DSM functionality, and also the kind of alerts. Do they come to the driver, or the alerts go to the software bit, to the people in the control room? That's one. Two,
Okay.
we've seen that on the all-in-one, we can add an extra camera.
Yes.
So which type of external cameras? No, like the others, it requires an external camera for it to work. So which type of camera is that in a specific that can do the others function? Then
Okay.
and the other one is the surround view camera. Does that camera give you a full picture of the all the lens, like all the sides of the vehicle, front, back, the two rear sides? Is it like a fish eye, something like that? If so, how is it installed?
Okay.
Then can the video intercom be used in the all-in-one, or in the all-in-one, or it's only in the MDVR? So the intercom, the voice intercom.
Okay.
Lastly, you showed a photo and a case study of where the system has been used, and I saw it connected on the screen of the car.
Yes.
So is it possible to connect to the inputs of the vehicle instead of having an external screen? Those are my questions. Thank you.
Okay. Okay. So to respond to these questions about the DSM camera, I'll just prefer to go to it. Number one, DSM camera is installed facing the driver. This is how it would look like. This camera, the advanced driver assistant camera, is facing the road, but you see the note is it requires a DSM camera to work efficient, to do the DSM functionality. This one has a built-in DSM camera and can take 3 more cameras. So on all the DSM features, this is the typical image you'll get. It's actually like an IR camera, and it will give you the alerts inside the vehicle. While you're driving, you as a driver, you'll get the notice to avoid maybe fatigue driving, avoid distraction while driving. When you get this alert in the vehicle, it is also synchronized at the same time so that someone at the control center is also aware this person is driving and making calls. In the vehicle, because these devices usually have a speaker, it will even tell you avoid making phone call while driving. The same thing, remove where IR blocking glasses, like it will warn you on the instant while on the vehicle. Then from the center, they will get the notice and they can use this to do enforcement. Then for all-in-one advanced driver assistant camera supports, so it is this all-in-one advanced driver assistant camera. So which camera, because I mentioned 3 external analog cameras input. So the answer is 3 external analog cameras input. So like this model will require this specific camera as one of the 3 cameras. Then we give it, let me just go back to the camera highlight so that I can. So we have this dash camera facing the road, the advanced driver assistant camera, and it can take any of these HDCVI analog cameras based on the application case. The same logic for this driver status monitoring camera, it will take one advanced driver assistant camera plus any of these other HDCVI. It can't be IP, it is only HDCVI cameras. So that is the logic for that all-in-one advanced drivers cameras. So that is the external camera. Then for the surround view camera, I mentioned that it's not yet out, this one. But the logic is we would put, you see there is a surround view terminal, then the camera is 1, 2, 3, 4. So it is not one camera. Instead, I will install one camera on this side, one camera in the front, one camera at the back, and another camera on the side. Then it will, when it goes to the terminal, it can now give us that typical simulation of the 4 views, and then we can get notification for things like blind spot detection. So it is not really a fisheye, but it's actually multiple cameras and it's coming soon. So it's going to be out. Once it's out, maybe we can arrange so that we get one set for demonstration and trial. Then, so for video intercom, the logic is, you see, for intercom to work, we need a microphone and a speaker on both sides. So in the vehicle, like let me use this model. You see it has two-way audio, which means it has mic and it has a speaker. So someone at the center can get notification and then I can talk directly to the driver from the center. The same logic, if whatever the driver is saying here, I can also hear it from at the center. So that is the two-way intercom talking. But we add an extra functionality of this device. Where is it? This intercom microphone. So for this vehicle, let's say it's a bus, you see it's a very big vehicle and maybe whatever the driver wants to communicate at the back may not be clear, so they can also use it to do a vehicle public address kind of release. So it's serving 2 purposes and it's also two-way, both to the vehicle and center, and then to address the people, maybe the passengers within the vehicle. Then for this case, you asked about Sorry, let me just share it again. Typically, it is that case that I should share. Uh, oh. So for it was this police car project. So you're asking if it supports connecting to the vehicle inputs, and I'll tell you this. The question is, what vehicle input does it take? Because, for instance, we can have HDMI or VGA out. So if the vehicle's input supports that, then we can just directly connect to it, and then we're able to display. And most of the time when it comes to these big numbers, of course, we can get customization, like 1,000 police cars. The manufacturer will even give you a provision so that you can do that level of integration. So by default, yes, it supports doing that integration to view and to also do the customization based on the design and what you have. But this mobile solution would actually adapt to the specific vehicle requirements, and we can customize based on the specific quantities and application requirement. So I hope this clarifies the questions you had. Yeah.
Yes, me, I'm good.
Okay. I don't know if we have any other question. Uh, Kindly just write for me your emails in the chat function so that I share the summary of this presentation so that we're on the same page. If we don't have any other question, you just write the email, then we are going to end this meeting. Then from there, I have a set here. I don't know the best way we can do a live demo for some of these products, but I can even provision the virtual environment to test for the technical team that will be handling this. So I will think about a way, then we can schedule maybe another hands-on where everything is recorded and then we're able to see how it's actually done. So just write your email and then uh, that will be it. So that marks the end of this training. I'm going to arrange for that practical bit so that we're also able to experience this. I don't know if we can arrange to get a sample for ISS. Maybe we can consider that as a future uh, requirement and then see the best way forward. So thank you so much for attending this training and thank you for your time. Let's look forward to more. We can now exit the meeting.